name is Hazem, and today we're going to learn about series circuits. So this is the most basic of circuits. We're continuing from last time, and remember we got our voltage here, so we've simplified it. We got our negative side and our positive side, and electrons are flowing around here clockwise and back to the positive side, and we've got three loads, also three sources of resistance. So here we got a voltage drop across each load. So the voltage drop, and we've got a current going across each load. So current is measured as I1, I2, and I3, and then IT, which is the total current of the circuit, is important. And then we've got V1, V2, and V3, which are the voltage drops across each load, and R1, R2, and R3 are our resistances across each load. Now, this is what we call a schematic diagram. So this could be a building. We're just looking at how things are actually connected without thinking about physically what they look like or how long the wires are or whatever. But we're just gonna assume that wires have no resistance, which is a lie, which we'll deal with later. But for right now, we're thinking that the wire itself doesn't have any resistance, even though it does. And these are not to scale. So this is our standard circuit, and we can draw a series circuit as a loop, like a circle, from negative to positive, or we can draw it like what we call a ladder. So this is the same. You can imagine that this is, we've just moved the voltage source. So this is just like a loop, but we draw it as a ladder style, but they're both the same. So when we have a um, a fuse or whatever, or any kind of device, we want to measure the resistance here. So this is what's called an ohm meter. An ohm meter can measure, this is a multimeter, so it can measure everything. But for the purposes of measuring amp, we call it an ammeter, or we call it a voltmeter if we're measuring volts, or we call it an ohm meter if we're measuring ohms or resistance. So here we've got a device, a fuse or whatever it is, and we're trying to measure the resistance. So we turn our multimeter to the ohm setting, and then we measure resistance, and it's sending a very small amount of electricity through, and it knows the current and it knows the voltage, so it can use that to calculate the ohms. But if this was broken, like here we cut it, for example, now we get OL, or open loop, as our measurement. We don't get any ohms. That means it's cut. So here in our series circuit, we forget about the current, but the total resistance of our circuit, when we have multiple resistances, we just add them up. So 25, so the total resistance here is 25 plus 30 plus 10, which is 40, 50, 60, so 65 ohms. And so here's a ladder circuit. We don't know the E, so we don't know anything, but we can guess. So we can draw it out like this as well. But now, going back, we can measure the voltage across two or any resistor here. So we just connect our voltmeter in parallel on 2 points of the circuit, and there's no electricity flowing here or here, but we got, for a very tiny amount, I should say, because V, remember V equals I R, so V, I'm gonna erase that, it's messy. So V equals IR, so that means I equals V over R. So to get our current really, really low, we would increase our resistance really high. So what the voltmeter does is it uses a very high resistance here, so it's not draining power from the circuit, but it can measure the voltage across a resistor that way. And we connect it in parallel with our load here, so we can get the voltage reading. So in a closed circuit or a closed loop, the sum of the voltages must be 0. So that means that if we got, mind you, these are so messed up, but so this is telling us we got 48 volts across. Oh, sorry, we got 40 volts and we got 32 volts. So here we've got 30 ohms of resistance and we've got 48 volts across it, and we've got 40 across here and we've got 20 across here. So that means that we can add these up. So 48, we're reading what's on the screens here, plus 40 plus 32, that's 120 volts. Although technically it's negative 120 volts because the voltage drop here is opposite what it is here. So you don't want to make that mistake because you end up with, you want to end up with 0. So again, we can do this a different way. So here we've got a ladder diagram, and we know this is 32 and this is 46, and the total is 120. So what's this one? So we can do 120 volts minus 32 minus 46. So that's equal to, so 46, that's 20, that's 42 volts. So with 42 volts of resistance here. So now remember, now finally we've got current. So current is the flow of electrons and it's measured in amps, and we can use the ammeter in series. So remember I told you earlier IT. So the current is the same everywhere in the circuit because there's only one pathway. So here, 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 it's all the same. So if I've got a circuit here, what's the current? So IT is equal to I1, which is equal to I2, right? So the current here and the current here is the same. If we want to know what the current is, we just go V equals IR and solve for I. So I equals V over R, which is, now our voltage here is here, 120 volts. And our resistance is 40 plus 20. Remember, we add them, so we got 60 volts or 60 ohms, right? And then that's equal to 2, so 2 amps of current. Any questions? Okay, so again, what's the current and what's the voltage drop across each resistor? So V equals I R. So we don't know V and we don't know I, but we can solve for I again. So I equals V over R, which is, now we know that the sum is 0. So we know this is V1, let's say, and this is V2, and this is V3. So we know V1 plus V2 plus V3 is 120 volts, right? So V1 plus V2 plus V3 is 120 volts. So if we go back here, we know 120 volts divided by resistance, and we know that the total resistance R is 30 ohms from here plus 25 plus 20, so 30, 40, 50, so that's 75. So 75 ohms. I don't have a calculator, but it's oh, I'm gonna get on my phone, and then so it didn't work out too bad. So that's 1.6. Oops. So that's here. So it's 1.6 amps, and then so now we know that the current is 1.6 amps across everywhere. So now we can use that to calculate each of these. So if we want to know V1, for example, where's my pointer here? So V1 equals I times R1, which equals 1.6 amps times 30 ohms, and V2 equals I times R2, which is equal to 1.6 amps times 25 ohms, and V3 is equal to I times R3, which is equal to 1.6 amps times 20 ohms. So this is equal to 3, this is 4.8, right? 6 times 3 is 18. 4.8. Oops, sorry, I messed that up. So that's 48 volts, and this is 1.6, so that's 25 and this is 40 volts, and then 1.6 times 20 is 20. This is 32 volts. So, and if you add these up, you should get 120 volts. So if you didn't, then you screwed up somewhere. So yeah, we got 120 volts. Any questions? Please post a comment. Thank you.